Hello everyone, I'm Jan Mold, Deputy Director of Competitive Events for HOSA-Future Health Professionals. Today I'm going to be talking about math for the health professions, basic to pharmacy. I didn't have a lot of students coming into my classroom saying, "Oh, I hope we're going to do math today, Miss Mold." A lot of people have some issues with math, but I'm going to promise you that in the health sciences, you're going to be using the math you learned. So we're going to start with some conversions, and there's some things that will really help you as you move through. And that would be learning that a kilo is 1,000, centi is 100, deci is 10, milli is 1,000, and micro is 1,000,000. Those are going to make your conversions easier once you memorize those. We're going to talk first about length. 1 meter equals 100 centimeters equals 1,000 millimeters. So again, those conversion factors that I gave you at the first are going to be really helpful as we move through this metric system. For weight, 1 kilogram equals 1,000 grams. 1 gram equals 1,000 milligrams. 1 milligram equals 1,000 micrograms. One liter equals 1,000 milliliters, and please note milliliters is written lowercase m, capital L. 10 centiliters equals 1 deciliter, 10 deciliters equals 1 liter, and 1 cubic centimeter, which is abbreviated cc, equals 1 milliliter. And those are used interchangeably. So ml, cc, same thing. All of these conversions are taken from the medical math guidelines, so you can go and look at those printed out for your use. 240 milliliters equals 1 cup. 1 cup equals 8 ounces, and it also equals 16 tablespoons. 30 milliliters equals 1 ounce equals 2 tablespoons equals 6 teaspoons. 15 milliliters equals 1 tablespoon equals 3 teaspoons. 5 milliliters equals 1 teaspoon. 1 milliliter equals 15 drops, which is abbreviated GTTS. And 0.0667 milliliters equals 1 drop. Weight conversion, 1 kilogram equals 2.2 pounds. And the way that I remember that is kilograms is always smaller than pounds. 1 pound equals 16 ounces. One meter equals 39.4 inches, and 2.5 centimeters equals 1 inch. And 1 foot equals 12 inches. So those are some helpful conversions that you would do well to memorize as you work in medical math. So let's talk about ratio and proportion. Ratio is the relative amounts of two quantities. Proportion is the expression of the equality of two ratios. And you're going to hear a lot about ratio and proportions. So here's an example. If 2 tablets contain 975 milligrams of ASA, which is aspirin, how many milligrams would be contained in 12 tablets? So you set this up. 3 tablets over 12 tablets equals 975 milligrams over X milligram. And then you solve for X. X milligram equals 12 tabs times 975 milligrams divided by 3. This example is really the same problem, just worked a little bit differently in that they're asking you to determine how many tabs. If 3 tablets contain 975 milligrams of ASA, how many tablets would contain 3,900 milligrams? So 3 tablets over X tablets equals 975 milligrams over 3,900 milligrams. So solving for X tablets equals 3 tabs times 3,900 milligrams over 975 equals 12 tabs. For concentration problems, if you have xyloclane liquid that contains 1.5 gram of lidocaine hydrochloride in 30 milliliters, what is the final concentration? So you put 1.5 grams over 30 milliliters, you divide 1.5 by 30, you get 0.05, multiply that by 100 to give you 5%. So that's the final concentration of lidocaine in 30 milliliters. Rogaine is a 5% solution of monoxidil in alcohol. How much active ingredient is in a 60 milliliter bottle? So X over 60 milliliters times 100 equals 5%. You're going to solve for X. X gram over 60 milliliters equals 5 over 100, and X equals 3. When you're looking at concentration, weight, and volume, you're going to put the active ingredient over the total quantity, and you convert to a decimal, and then multiply by 100. So really easy formula. For dilutions, you've got Q1 equals the initial quantity or volume. Q2 is the final or desired quantity or volume. C1 is the initial concentration in percentage, and C2 is the final or desired concentration in percentage. So Q1 times C1 equals Q2 times C2. So we're just going to fill in there from our problem. If you diluted 90 milliliters of an 8% benzocaine lotion to 6%, how much could you produce? So we're given the quantity, Q1 equals 90 mils. The concentration of 1 equals 8%. Q2 we're solving for, and we know the concentration that we want is 6%. So just filling in the formula, 90 times 8 equals X times 6. 720 equals 6X. X equals 120. Hopefully as we're going through this, you're seeing that oftentimes we make these much more complicated than we have to. So I'm going to encourage you, after we finish this discussion, you go back and look over the formulas, write those down, and do some practice on your own. You can find all kinds of medical math problems online. IV flow rate. TV equals the desired total volume. IR equals the infusion rate, and X equals the number of hours the bag will last. So you've got ordered 5% in D5W at 125 milliliters per hour. They want you to provide the solution is provided in 1,000 milliliter bag. So what you're going to have to do is set this up with the total volume over the infusion rate per hour equals X. And then you solve for X, and X equals 8. So the bag would last 8 hours. Again, you've done this in your math classes. It's just a different way of thinking about it. If you have to figure out the drip, you're going to put the total volume in milliliters times the drop factor over the infusion time in minutes equals the drops over the minutes. So you have normal saline ordered at 500 milliliters with 25,000 units of heparin infused over 8 hours. The drop factor you're given is 60 drops per milliliter. First thing we need to do is convert the hours to minutes. So 8 times 60 is 480. Then we're going to solve for the drops. 500 over 480 equals 1042. 1042 times 60 equals X. X equals 62.5 drops per minute. The last one I'm going to share with you is Alligations. This is used in pharmacy. You won't see it many places outside of pharmacy. First thing you're going to do is draw yourself a tic-tac-toe board. On the left upper corner, you're going to put the highest percentage. In the left bottom corner, you're going to put the lowest percentage. The question's asking in what proportion should alcohols of 95% and 50% strengths be mixed to make 1 liter of 70% alcohol. So what we want then goes in the center. So I've got my highest number in the upper left corner, the highest percentage, the lowest percentage in the left corner, and then what I actually want in the center. I'm going to go across here, and 95 and 70, the difference is 25. 50 and 70, the difference is 20. I'm going to add those two together. 20 plus 25 equals 45. I know I've got 1,000 as the total milliliters because 1,000 milliliters equals a liter. So to figure the 95%, I'm going to multiply 1,000 milliliters over 45 times 20, and I'm going to get 444. If I can stay on the correct page, we're going to be doing well. For the 50%, I've got 1,000 milliliters over 45 times 25. That's the difference between the two here. So 556 milliliters. I can check my work by adding those two together, and it should come out to what I desired, which is 1,000 milliliters. There's a lot of opportunities for you to practice your math and then compete with math. For middle school division, there's Math for Health Careers. For secondary and post-secondary collegiate medical math, we have Math for Healthcare Professionals in the ATC testing. Then there's also pharmacology and pharmacy science. Again, don't make it harder than it has to be. It's not that difficult. Thank you for your time.